All right, so our goal is to find the upper and lower sums for the region bounded by the graph of y equals x squared and the x-axis between 0 and 2. So let me draw this for you. Let me get a pencil and draw it for you. Okay, so we know that this is a parabola, okay? And we're only going from 0 to 2. So just, it looks something like that. Let's try that again. Okay, just pretend that's the parabola. And we want to find the area under that parabola, okay? So that's the area we're looking for, is this, if I could shade it, but I'm not going to because it's going to make things messy. So what we're going to do is we're going to make rectangles. Now, we want more rectangles, okay? 5 is not enough. 8's not enough. 16's not enough. What we want is like infinitely many rectangles, okay? So let me just sketch in some of these. I'm going to start with the upper sum. So I'm going to start with these rectangles that overhang like this, okay? And just pretend there's a ton of them there. So what I want to do is find the sum of all of those, okay? So what I want is the sum of the first rectangle, the area of the first rectangle, the area of the second rectangle, the third rectangle, and so on, for as many rectangles as we have. Okay, now the width of all of these rectangles, I'm going to call that delta x. And then the height of all the rectangles, that's determined by the function, okay? Because I have to plug in whatever this value is into the function, okay? And that'll give me that endpoint. And then whatever this value is, I plug it into the function. So I'm just going to call it, I think your book uses m sub I, okay? Just whatever rectangle it is. So this is what we're trying to do. Now, let's start with delta x. Delta x is, remember, that's the width of all of these rectangles. So I'm going from 0 to 2, and I'm splitting that from 0 to 2 into n rectangles. So I have an interval from 0 to 2 is 2, and I'm splitting it into n rectangles, which means that each rectangle is going to have a width of 2 over n. So that's my delta x. Now, m sub I, that is going to be this right endpoint, okay? So let me get this part in here. I equals 1 to n, and we know that delta x is 2 over n. Okay, so now we're focusing on this part. Now, m sub I, that's what we're plugging in for each of these, okay? So down here, if we're thinking along this axis, that first rectangle is going to happen at, remember, each of those rectangles is 2 over n. So my first rectangle is going to happen at 2 over n, and then another 2 over n from that, and then another 2 over n for times that. So this is going to be I times 2 over n. Okay, so that's how I find my spot in those rectangles. So we are doing f of I times 2 over n. Okay, now we're getting somewhere. Now remember, we want to do f of I over 2 over n, which if you want to rewrite that, that's f of 2I over n times 2 over n. So I'm just going to plug that 2I over n into the function, which is just x squared. So that gives me 2I over n squared times 2 over n. And I'm going to come up here and clean that up. So that's going to give me, see, 2 squared is 4 times 2 is 8. That was supposed to be an n. 8I squared over, that's going to be n squared times n, which is n cubed. All right. So now what we want to do is get this into a format that we can use those formulas from yesterday. So 8 is a constant, and actually n is a constant too. I mean, technically it could be 10,000 or a million or whatever. So I'm going to pull out 8 over n cubed, and I equals 1 to n of I squared. This right here is one of those formulas that's on page, what page was it in your book? 291? Yes, 291, or they're in the notes from yesterday. This right here is n plus 1, n plus 1, 2n plus 1 over 6. And this, of course, is just 8 over n cubed. Okay, so we're going to clean this up. I am going to start by canceling one of these n's. I might continue by at least reducing that. That might help a little bit. Okay, so in the numerator, I am going to distribute and FOIL this out. And that's going to give me, let's see, 8n squared plus 12n plus 4 all over 3n squared. And then my last step is I'm going to divide all of those by 3n squared. So 8n squared divided by 3n squared is just going to give me 8/3. And then 12n divided by 3n squared, I get an n that cancels, so I get 4 over n. And then 4 over 3n squared. Perfect. So that is the area of all of these rectangles added together, okay? And I can do however many I want. If I want 1,000,000, you just plug in 1,000,000 for n, and that's going to give you an area. Now, that is an area, that's the upper sum, okay? To do the lower sums, I'm going to have you go check the notes, check on the PDF notes in Google Classroom. I'm not going to walk all the way through this. The only difference for that is this thing changes. This part right here changes to an I minus 1. Okay. And you can follow through, but we're going to use kind of the same process. And it's going to give us a formula for the lower sum. And you'll see that on the notes. And again, you can plug in whatever you want. If you want 1,000,000 rectangles, you plug that in and that'll give you your lower sum. We will put this all together in the next video for some more delightful fun.